In the heart of the machine, where silence hum and circuits gleam, a language whispers, precise, refined and unseen, not loud like Java, nor swift like Python space, but deep like the roots that hold time in place. It's C++, forged in logic and steel, built for control, for speed, for things that feel real. Good day everyone! Today we're going to learn about a programming language called C++. C++. C++ is a general-purpose programming language that is widely used for developing software applications, system software drivers, operating systems, game engines, high-performance and real-time systems. It is known for its efficiency, flexibility, and ability to provide a high level of control over system resources and memory. Bjarne Stroustrup. He is the one who developed C++. It was initially called C with classes in 1979 at AT&T Bell Labs and officially renamed C++ in 1983, and it was made generally available in 1985. The different online C++ compilers. Popular online C++ compilers include Compiler Explorer or Godbolt for understanding assembly code, Pisa for coding with multiple files, Replit and Rextester for quick execution and collaboration, and specialized tools like Quickbench for benchmarking and CPP Insights for visualizing compiler actions. Now let's talk about what is a variable in programming. A variable is a symbolic name for a container that stores a data value. Think of it as a labeled box where you can keep information like numbers, text, or true false states, and then use or change that information later in the program. Next up are the different data types. First is we have derived. In C++, derived data types refer to data types that are built upon or composed of fundamental and also known as primitive or built-in data types. Here are the examples. Arrays. Collections of elements of the same data type stored in contiguous memory locations. Second, we have pointers. Variables that store memory addresses, allowing for indirect access and manipulation of data. Third is references. Aliases for existing variables, providing an alternative name to refer to the same memory location. Fourth is structures. User-defined data types that group variables of different data types under a single name, allowing for the creation of custom data structures. Lastly, classes, the foundation of object-oriented programming in C++, similar to structures but with additional features like access, control, and member functions. Second is built-in. C++ provides a set of fundamental, or built-in, data types that are directly supported by the language and compiler. These types represent basic values and serve as a foundation for more complex data structures. The primary built-in data types in C++ include integer types, used to store whole numbers. These can be further modified by short, long, signed, and unsigned to control their size and range. Character types, used to store individual characters. Floating point types, used to store numbers with fractional part. Boolean type, used to store logical value. And the last part of the different data types is user-defined. A user-defined data type is a custom data type created by a programmer to group related data of different types into a single unit, allowing for more complex and structured data representation beyond the built-in data types. Some common examples include structures, classes, and enums, which are used to represent real-world concepts like a person or an inventory item by combining various data fields, such as name, age, and price, into one cohesive type. These are the operators in C++: unary, binary, and ternary operator. Now, here are the control structures in C++. But wait, what do you think is a control structure in C++? Control structures in C++ are programming constructs that determine the flow of execution within a program. They allow for decision making, repetition of tasks, and efficient management of program logic. C++ provides several types of control structures. First C++ control structure is the sequential. This is the most basic type where statements are executed one after another in the order they appear in the code. The second C++ control structure is the selection or decision making. This allows the program to execute different blocks of code based on whether a certain condition is true or false. The last C++ control structure is iteration or looping. This allows a block of code to be executed repeatedly until a certain condition is met. Conditional statements are programming instructions that control a program's execution followed by running different code blocks, depending on whether a condition is true or false. What are loops? Loops are control structures designed to repeatedly execute a block of code until a specified condition is met or a certain number of iterations are completed. They are fundamental for automating repetitive tasks and writing efficient, concise code. In C++, functions can be broadly categorized into two main types. First, we have standard library functions. These are predefined functions provided as a part of the C++ standard library. They offer a wide range of functionalities for common tasks, such as mathematical operations, input or output, string manipulation, and more. To use them, you typically need to include the relevant header file. The second one is user-defined functions. These are functions created by the programmer to perform specific tasks tailored to their program's needs. They help in organizing code, promoting reusability, and making programs easier to understand and maintain. The basic syntax of C++ involves several key elements. Header files. C++ programs typically begin by including header files using the #include directive. These files provide access to predefined functions and classes. Namespace help organize code and prevent naming conflicts. The SCD namespace contains many standard C++ features. Using namespace SCD allows you to use elements from the SCD namespace directly. Every C++ program must have a main function, which serves as the program's entry point. Execution begins here. It is typically declared as int main, indicating that it returns an integer value. C++ code is composed of statements which are instructions to the computer. Each statement must be terminated with a semicolon. Comments are used to explain code and are ignored by the compiler. Count, character output, is used with the insertion operator to display text or variable values on the console. Kin, character input, is used with the instruction operator to read user input. The return statement indicates that the program executed successfully. In C++, a calling function is a function that initiates the execution of another function. In C++, parameters and arguments are distinct but related concepts used when working with functions. Parameters are the variables declared in the function's definition or prototype that act as placeholders for the values that will be passed into the function. Arguments are the actual values or expressions that are passed to a function when it's called. Lastly, function overloading in C++ is a feature that allows multiple functions to share the same name within the same scope, provided they have different function signatures. The function signature is defined by the number, type, and order of the function's parameters. The return type of the function is not part of its signature for the purpose of overloading. That's it, hope you all learned. So here we pause our journey down through headers, heaps, and function fun. May you code not just to build, but to feel the silent beauty of the steel.